Hi, in this video I want to talk about electric potential energy, the goal being just a basic conceptual understanding of what it is and what the difference is between a high energy arrangement and a low energy arrangement. So let's get started. I want to show you this. This is the rubber rod causing the electroscope to move. I'm seeing that knob move a little bit. It has kinetic energy. Where did that kinetic energy come from? I'll wait 3 seconds and then I'll move on. Might have guessed it. You can see the person is rubbing the rod on the fur. They are doing work on it. And that's where the energy is originally coming from. What I want to hone in on, though, is when the person is doing work on it, where is that energy stored? You might have guessed it. It's not kinetic energy. It's not gravitational potential energy. It's not thermal, and it's not rotational. It's something new. It's something different. It is electric potential energy. When the person rubs the rod on the fur, they are creating an arrangement of charges, and there is energy associated with that arrangement of charges. That's the basic gist of it. So diving deeper, what is the difference between a high energy arrangement and a low energy arrangement? Let's build on an analogy to gravity. So take a look at these setups, this one up top and then this one on the bottom. Which configuration has a higher gravitational potential energy? This system up here or this system down here? It is the top one. I got 2 ways to convince you that it's this one. So the first one is, hey, just look at a planet in its orbit around, let's say, the sun. The gravitational energy is greatest there and least there. How do you know? Because the total energy in the system, the two-body system, is conserved, no outside external net force. So when it's slowing down, over here it's really fast, and over here it's really slow. So when the kinetic energy is low, that's when gravitational energy is greatest. So it's moving slowest over here. So that's one way to think about it. Planets actually in their orbits. And building on that a little bit is this simulation over here. Basically, imagine you start the two bodies at rest. So let's say, two objects. If they start off with zero initial velocity, and again we're talking about gravity, then what would happen? They would accelerate towards each other. In the video, you're seeing the sun's not moving very much because the mass is so massive. But I hope you also notice that this one down here, it's so close to the sun that it doesn't have much space to accelerate over. So the final speed it reaches is very small compared to over here, where the force is smaller down here, but it has so much more time and distance to accelerate over. So it reaches a higher final speed. That speed that it reaches just before colliding, that's kinetic energy. And where did that kinetic energy come from? It came from the gravitational potential energy. So this is getting more kinetic because it's starting with more gravitational potential. And this, you're not going to be able to get much kinetic out of it because there's less gravitational potential to start with. So to summarize, to think about whether it's a high energy or low energy arrangement, think about how much kinetic energy you could get out of it if you were to release the masses and see what would happen to them. Another way to look at it is the work done by the force. When the distance is larger, the force has more time, or I'll just say the work done by it is greater. W is equal to F times D. Just with a little asterisk, the force isn't constant, so keep that in mind. You should think of it as sort of the average force over that distance. Okay, moving on. How does this relate to the electric force? Well, we can use a similar trick to know whether an arrangement is high electric potential energy or low electric potential energy. Basically by releasing the charges and imagining how much kinetic energy we would get out of that. So I'm going to go through some examples. You're welcome to download the slides or follow along in the video.